Welcome to CS track. Let us discuss a important part of balancing of equations, that is n factor. N factor, generally it is indicated with the symbol that is NF. NF stands for what? N factor. Whereas this n factor is having a good relation with the gram molecular weight as well as gram equivalent weight. We always come across two particular words in chemistry. One is gram molecular weight, that is gram molecular weight, and other one is what? Gram equivalent weight. This is gram equivalent weight. This gram equivalent weight and the gram molecular weight are interrelated with a new logical parameter, that is n factor. N factor times of gram equivalent weight will becomes equal to gram molecular weight. So n factor indicates the many times the many number of gram equivalent weights present within the gram molecular weight. That particular number or a fractional value is said to be what? N factor. By definition, the many number of gram equivalent weights present within 1 gram molecular weight. The many number of gram equivalent weights present within 1 gram molecular weight present within 1 gram molecule weight. 1 gram molecule weight is known as its n factor. Moreover, n factor for a particular component depends on the reaction, depends on the condition, depends on the medium, etc. The same material doesn't maintain same n factor value based on the reaction conditions, based on the medium. It depends. N factor may, in majority of the cases, it can be a number. It can be a simple number. It can be a fractional value also. Everywhere this n factor is a positive term. N factor is what? A positive term. It never be negative. So n factor indicated with NF, generally known as n factor. Whereas it is very important to interrelate the gram molecular weight as well as gram equivalent weight. The n factor times of gram equivalent weight will becomes equal to gram molecular weight. Whereas the many number of gram equivalent weights present within the 1 gram molecular weight is known as its corresponding n factor. N factor in majority of the normal reactions will becomes equal to a positive number. Whereas in some other cases, exceptionally, we also found that this particular value also equal to some fractional value. But in any case, it is a positive value, it never be negative. That is n factor. Now we will go for calculation of n factor of different components and different varieties of reactions. Especially, it is calculated for the redox reactions. There are different varieties of redox reactions. Yes, redox reactions, simple redox reactions, whereas one particular component is involved in more than one oxidations, more than one reductions, conproportionation, disproportionation. Like this, based on the different varieties of possibilities of the redox reactions, how to calculate the n factor on behalf of each particular subtopic wise. Let us have a elaborated brief discussion for the calculation of n factor. Everywhere it maintains the relation, that is gram equivalent weight into n factor times will becomes equal to what? Gram molecular weight. Calculation of n factor in simple redox reactions. Simple redox reactions are those reactions in which one component undergoes oxidation and another component undergoes reduction, whereas that is a redox reaction, one in them undergoes oxidation and the other component undergoes the reduction. Whichever undergoes oxidation known as reducing agent, whichever undergoes oxidation is known as oxidizing agent. Reducing agent is different and the oxidizing agent is different. If I know the reducing agents or if I know the oxidizing agents, if I know the change in oxidation number with respect to the central atom or the core atom of the oxidizing agent and the reducing agent, on behalf of that, the simplest case for the calculation of n factor, we will go for the examples, we will write, thereby we will calculate the oxidation numbers, we will go for the calculation of difference in oxidation numbers for the oxidizing agent as well as the reducing agent. Thereby, here itself we will calculate the n factor value. Here are some components related to the simple redox reaction related, whereas the component that is MnO4 minus, whereas this manganese is maintaining +7 as its oxidation state. This +7 oxidation state containing compound is converted to Mn2 plus, appears as what? Reduction. Whereas this is a reduction, this component is participating in the reduction. It is reducing its oxidation number from +7 to +2, whereas here the oxidation number is +7. I am making it as a round, whereas the same compound of manganese is converted in the product with the oxidation number of +2. This change in oxidation number, that is delta oxidation number, can be given by product oxidation number minus reactant oxidation number. Before going to that one, we should be very clear that the number of central atoms, you ignore all other atoms, whereas the central atom is manganese, one manganese versus one manganese. Law of conservation of atoms, law of conservation of central atom has to be maintained. After looking this, if I take the magnitude, because we said it is always a positive number, 2 minus 7, that is 5. 2 minus 7 implies what? 5. Here this is said to be what? N factor. N factor of manganate MnO4 minus in this particular reaction is found to be what? 5 is the N factor value. Suppose the second case, there is a compound with the oxidation number of ferrous as +2. That +2 oxidation number compound is converted to +3. Whereas in this case, this N factor is also for ferrous. Law of conservation of maintaining, by maintaining law of conservation of ferrous atoms, one ferrous maintained is in the product with one ferrous, whereas change in oxidation number, that is 3 minus 2, is found to be 1. Hence N factor will becomes equal to 1. Whereas if I go for the case number 3, this is oxalate. If I write the structure of oxalate also, this is oxalate structure. C double bond O followed by O minus. This oxalate is converted to carbon dioxide. This is carbon dioxide. Whereas law of conservation to maintain with the central atom, that is oxygen, here it is to be 2 carbons. Whereas oxidation number of carbon in the starting material is 3. Whereas for the product, here the oxidation number is 4. For carbon, change in oxidation number is 1. Such of 2 are there, and N factor becomes equal to 2 into 1 is equal to what? 2 is the N factor. Similarly, if I go for the case number 4, this is chromate, whereas chromium maintains +6 as the oxidation state, and that is converted to Cr3 plus to maintain law of conservation. Here 2 chromiums are required, whereas in the beginning these 2 chromiums maintains 12, in the product these 2 chromiums maintains 6. So for every molecule of chromate ion, that is difference is 6 minus 12 magnitude divided by 2, that is 6 by how much is this? This is chromium. For chromium it is, for 2 chromiums it is S. For 2 chromiums, because here one molecule is consisting of 2, hence N factor becomes equal to what? 6 for this particular chromate ion. Similarly, there is a special reaction in which MnO4 minus is converted to Mn2 plus and the Mn3 plus, Mn6 plus. The balanced equation is maintained like this. So this is half balanced equation. This is reduction. Reduction half balanced equation maintains such of relation. In this case, in order to calculate this N factor value, product oxidation number of central atoms 2 plus such of 2, that is 4 plus 1 manganese maintains 6 minus of, here this particular one maintains +7 is oxidation state. This is happened for 3. So therefore this is 10 minus 7, 3. 10 minus 7 is equal to 10 minus, this is +7 is oxidation state. Here it maintains 2. 2 plus 2 into 2, 4. 4 plus this manganese maintains 6. Overall it is 10. 6 plus 4 is equal to 10. 10 minus, here this manganese maintains 7 is oxidation state. 10 minus 7 is equal to 3. This is possible for the 3 MnO4s. So therefore for MnO4 it becomes equal to, there is a slight difference. Here this is also 3 manganeses. 3 manganeses stands for, this is 7 for 1. So therefore for 3 manganeses, 7 into 3, 10, 21, that is 11. Magnitude it is 11 by 3 is the N factor value. The last case, it is a non-stoichiometric equation. Once again I will re-explain. This 4 comes from the 2 manganeses. This 6 comes from the 1 manganese. This is product oxidation number of manganeses of 3 in number. Whereas for every manganese of starting material, oxidation number is 7. Such of manganese by number 3 are there. 7 into 3 will becomes equal to 21. Total 10 minus 21, it reaches as 11 magnitude. This 11 is for 3 MnO4 minuses, hence for each MnO4 minus it becomes 1/3 of that one, reaches as what? 11 by 3. Whereas the last case here, a non-stoichiometric reaction was there. Fe 0.95 and O is converted to Fe3 plus. If I write this particular part here where space is there, here I am making a box to write the things. Whereas in the starting material, ferrous, and product material, ferrous related oxidation numbers for ferrous atom in the product oxidation number is 3. Whereas for ferrous atom, the oxidation number, if I calculate, for 0.95 ferrous atoms oxidation number is 2 only. So therefore this is 2 by 0.95 for 1. So therefore change in oxidation number reaches as 3 minus 2 by 0.95. Whereas this will becomes equal to N factor. This is product oxidation number for 1 ferrous atom. This is reactants 1 ferrous atoms related oxidation number. It total will reaches as 3 times of 0.95 minus 2 divided by 0.95. So after calculation we will be getting the value in this way for the simplest redox reactions involved components, whether that may be an oxidation process, that may be a reduction process, N factor value is generally calculated. Yes, this is the second variety of calculation of N factor known as intra-redox reaction. For some particular compound, one element undergoes oxidation. From the same compound, some other element undergoes reduction. Such of reactions are said to be a special case of redox reactions known as intra-redox. Suppose if I go for potassium chlorate, this potassium chlorate is converted to potassium chloride followed by what? Oxygen. Whereas here chlorine maintains plus 5 is the oxidation state, whereas here chlorine maintains minus 1 is the oxidation state. From this it is clear that it is undergoing reduction. Whereas oxygen maintains minus 2 is converted to 0. So therefore this is what? Oxidation, increment in oxidation number. This is what? Decrement, that is reduction. This is what? Oxidation. Similarly this is ammonium chromate. On heating it is converted to nitrogen followed by Cr2O3 followed by water. In this nitrogen maintains minus 3 oxidation state, whereas here chromium maintains plus 6 as oxidation state, whereas this particular chromium ammonium of minus 3 is converted to nitrogen of 0 implies this is increment in oxidation number, that is oxidation. Whereas if I go for the chromium, this total will becomes equal to plus 2 implies Cr2O7 2 minus Cr2O7 2 minus implies chromium is maintaining plus 6, and here chromium is maintaining plus 3, that is plus 6 is converted to plus 3. This is decrement in oxidation number is known as what? Reduction. So from the same compound, one element, here chlorine, undergoing decrement in oxidation number known as reduction. Oxygen of the same compound, potassium chlorate, is undergoing increment in oxidation number is known as what? Oxidation. Similarly from this ammonium chromate, nitrogen of minus 3 is converted to nitrogen 0. Nitrogen is also belongs to ammonium chromate. Chromium is also, which is participating in reduction, is also belonging to same ammonium chromate. In that case, for this particular compound consisting different elements which are participating both in oxidations and the reductions, either you can go for the oxidation change in N factor with respect to oxidation, or N factor with respect to reduction will becomes equal to N factor of the compound. Suppose for the N factor of potassium chlorate, N factor of KClO3, I can consider this is equal to either N factor of chlorine atom which is undergoing reduction, or this is also equal to N factor of oxygen which is also part and part of potassium chlorate. If I go for the potassium chlorate, how many chlorines are there? 1 chlorine. Whereas oxidation number of chlorine in the starting material is 5 plus 5. In the product oxidation number is found to be minus 1, whereas the difference will becomes equal to minus 1 minus of plus 5, that will becomes equal to minus 6. Its magnitude reaches as what? 6 is N factor with respect to the reduction. Similarly, I can also consider this one with respect to oxygen. Oxygen is here minus 2 is oxidation number is converted to 0. For oxygen it is 2 n factor, whereas the number of oxygens present in the entire molecule are 3. Hence in the second case also 3 into 2 will becomes equal to what? 6 is n factor. Similarly, with respect to ammonium chromate, nitrogen maintains here -3 as the oxidation state, whereas this -3 of such of nitrogen's by number are 2, that is total -6 is converted to 0, difference will becomes equal to 6, hence n factor with respect to nitrogen 6. Similarly, with respect to chromium maintains +6, 2 chromiums are +12 minus 6, it also becomes equal to what? 6. Thus, for the same compound, different elements participates both in oxidation and the reduction. Then either from the oxidation involved element or from the reduction involved element, you can calculate n factor that will becomes n factor of the compound having different elements. Thus here for the potassium chloride, either with respect to chlorine you can calculate, or with respect to oxygen also you can calculate, that will becomes equal to n factor. This oxygen's related calculation also becomes equal to potassium chlorate related n factor. Similarly, with respect to this oxidation involved component element, that is nitrogen, or with respect to chromium, if I calculate, that reaches as what? 6. Whereas every particular component maintains its own oxidation number. Suppose if I go for this oxygen, which is a compound involved in the transformation, its n factor reaches as S. Here it reaches to 0 oxidation state from the -2 oxidation state. For oxygen it becomes equal to 2, such of oxygen's numbers are 2, hence n factor with respect to this O2 will becomes equal to what? 4. Similarly, if I go for this KCl related oxidation number, this is -1, whereas it is present from the +5, hence change in oxidation number is 6. Hence for this potassium chloride also, that n factor will becomes equal to 6. It may something else in other cases, but here it matches with the potassium chloride. Thus, n factor of intra-redox reactions can be calculated. The next one is the calculation of n factor in the DP reactions, that is disproportionation reaction. One component participates in oxidation and the same component participates in the reduction. The element with the intermediate oxidation state is converted to higher oxidation state product, and the other one is lower oxidation state containing product. For the same element of the same compound, one is participated in oxidation and other is participated in the reduction. For that we have to calculate the n factor. Here these are some examples of disproportionation reaction in which hydrogen peroxide is converted to water followed by oxygen. Chlorine basic medium is converted to Cl minus chloride followed by chlorate. Similarly, H3PO4 is converted to phosphine followed by H3PO4. Whereas here oxygen maintains -1 oxidation state, here -2 as well as 0. Chlorine maintains 0 oxidation state, here it maintains -1 and +5. Whereas here H3PO4, that is H3PO3, it is a mistake. This is +3 oxidation state, this is -3 followed by +5. Like this, the element present in a compound of intermediate oxidation state is converted to different compounds in the form of product components. One in them is having higher oxidation state, other in them is having lower oxidation state. For that particular case, for the calculation of n factor, we have a rule, that is 1 by n factor will becomes equal to 1 by n factor of oxidation plus 1 by n factor of what? Reduction process. Like this, we have to calculate the n factor of disproportionation reaction. Suppose if I go for the hydrogen peroxide, here I am having a space. If I write the hydrogen peroxide conversion to water molecules, this is 2H2O. Hydrogen peroxide is converted to water molecules. Here my main atom is oxygen, 2 oxygens equivalent I wrote, it is 2 water molecules. Hence this particular process -1 is converted to -2 implies reduction, whereas this n factor of reduction value can be given by -1 is converted to -2. For every particular oxygen atom, the difference in oxidation number is 1. There are 2 oxygens implies that is 2. So therefore n factor of reduction will becomes equal to what? 2. Similarly, if I write oxygen related balanced equation with respect to the reference atom, that is oxygen, like this. This -2 is converted to 0. This is oxidation, then n factor of oxidation will also becomes equal to 2. Hence, the total n factor 1 by n factor will becomes equal to n factor of oxidation plus n factor of reduction is equal to 1. 1 is equal to 1 by 1. So, therefore, n factor of hydrogen peroxide in this decomposition becomes equal to what? 1. That will becomes equal to 1. Similarly, the n factor of Cl2 in disproportionation reaction to Cl minus followed by ClO3 minus can be given by, if I write the reduction related, this is 2Cl minus. Similarly, if I write the oxidation related, that is converted to ClO3 minus, that is also 2. Whereas this is a reduction, n factor will becomes equal to n factor of reduction will reaches as 2, whereas this n factor of oxidation reaches as what? 10. So therefore 1 by n factor, the original n factor will becomes equal to 1 by 2 plus 1 by 10. I can write it as this is 5 by 10 also. 5 by 10 plus 1 by 10, that is 6 by 10. If I take reciprocal, n factor will becomes equal to 10 by 3, that will 10 by 6, that reaches as what? 5 by 3 is the n factor value. 5 by 3 is the n factor value. Similarly, the next case for the n factor of H3PO3 can be given by, if I go for the reduction, this H3PO3 is to be converted to PH3. Whereas this is reduction, this plus 3 is converted to minus 3, hence n factor of reduction will becomes equal to what? 6. Whereas n factor of oxidation reaches as, here 3 is converted to 5, 1 phosphorus versus 1 phosphorus. Law of conservation is maintained. So therefore that will reaches as what? 2. So net n factor will reaches as 1 by 6 plus 1 by 2. I can write it as 1 by 6 plus 3 by 6 also. That is 4 by 6. 4 by 6 implies n factor reaches as 6 by 4 is equal to what? 3 by 2 is the n factor. In this way, n factor of chlorine, n factor of hydrogen peroxide, n factor of H3PO3 can be calculated. This is n factor of this. Whereas if I want to calculate n factor of phosphine, minus 3 is converted to plus 3. Hence, for phosphorus, change in oxidation number becomes equal to 6. Hence, n factor will becomes equal to 6. Here, plus 5 it reached from plus 3. For phosphorus it is 2, hence n factor will becomes equal to 2. This is n factor of H3PO4 2. This is 6 is n factor of H3 phosphine PH3, whereas for this H3PO3 that n factor as we calculated here, it reaches to a value of 3 by 2. The n factor of conproportionation reactions, the reactions in which the intermediate oxidation states containing species till now are converted to higher and the lower oxidation states, but it is a reverse process in which compound is having elements with lower and the higher oxidation states are converted to one particular compound having intermediate oxidation state for the element. For those particular reactions, calculation of n factor. Now calculation of n factor for the N2O, which is a part and part of conproportionation reaction. Here nitrogen maintains minus 3 state, nitrogen maintains plus 5 state, that is converted to nitrogen of plus 1 state. If I write n factor of oxidation can be given by, here plus 1 is converted to plus 5, a difference of 4 for 2 nitrogens, it is 4 into 2 is equal to how much? 8. Similarly, n factor of reduction, if I write, that is a reduction, whereas this plus 1 is converted to minus 3, for nitrogen difference is 4, such of nitrogens by number 2 implies this is also 8. So therefore total n factor will becomes equal to 1 by n factor of oxidation plus 1 by n factor of reduction, that will becomes equal to 2 by 8. If I take the reciprocal, net n factor will becomes equal to 8 by 2 is equal to 4. 4 is the n factor for the N2O. Similarly, for this N2 calculation, here nitrogen minus 3, here nitrogen it maintains what? That is plus 3 is the oxidation state. Whereas n factor of oxidation and the n factor of reduction, if you calculate, 0 is converted to plus 3. So for nitrogen it is 3 implies, for 2 nitrogens it is 6. For nitrogen it is minus 3 and 3 implies this is also 6. Net n factor will becomes equal to 1 by 6 plus 1 by 6 is equal to 2 by 6. n factor value reaches as 6 by 2 is equal to what? 3. 3 for what? N2. Thus, n factor of Kahn proportionation reactions is to be calculated. The next important case for the calculation of n factor is calculation of n factor for a compound in which many atoms either undergoes a set of reactions like unique oxidation or the reduction. Yes, these are the reactions in which the compound related elements participates in the unique type of process, maybe that is oxidation or that is reduction. This is the case known as ferrous oxalate participated in the reaction in which ferrous of +2 state is converted to +3 state and oxalate 2 carbons are there to maintain law of conservation of central atom. 2 carbon atoms are to be maintained. Here ferrous +2 is converted to ferrous +3 and carbon +3 is converted to carbon +4. Now the total change in oxidation number which results as n factor because the whole things are participated in the oxidations can be given by with respect to ferrous. For ferrous atom change in oxidation number is 1. For carbon atom change in oxidation number is 1. Such of carbons by number 2, hence 1 plus 2 reaches as what? N factor reaches as 3. Similarly, this is Cu3P is converted to Cu2 plus followed by H3PO4. If I write the oxidation number, ferrous maintains -3, counterly copper maintains +1, whereas in H3PO4 oxidation number of phosphorus reaches as what? 5. So here for number of copper atoms n factor will becomes equal to 3 times because 3 copper atoms are there. +1 is converted to +2 implies 1, whereas number of phosphorus is 1. Change in oxidation number will becomes equal to 8. That is 3 plus 8 reaches as what? 11 is the oxidation number. Whereas in this case FeS2 sulfur maintains -1 and -1, total it is -2. Each sulfur is maintaining -1, whereas ferrous is maintaining +2. Here it is maintaining ferrous with +3. With respect to ferrous, that is 1 into 1 plus. With respect to sulfur, there are 2 sulfurs. Sulfur with -1 is converted to sulfur with +4. +4 implies difference is 5. 5 implies 2 into 5, that is 1 plus 1 plus 10, that is 1 plus 10 is equal to what? 11 will becomes equal to the n factor value. So thus n factor has been, this is oxidation and this is oxidation, it is calculated. Now here Fe is from +2 state is converted to +3 state, whereas Cn total it is minus implies carbon +2 and the nitrogen -3 are the oxidation state with respect to number of ferrous as 1. So therefore difference is 1 plus, whereas carbons and the nitrogens a sum of +6 times. +2 is converted to +4. +4 implies this is 2. Whereas this is -3 is converted to +5. This is 8. Total will reaches as 1 plus 60. That reaches as what? 61 will becomes equal to the n factor. Whereas arsenic sulfide, this is -3. Whereas sulfur is what? -2. This -3 is converted to this is +3. +3 is converted to +5. Such of 2 are there. 2 into 2, that is 4 plus, whereas sulfurs by number 3. 3 into this -2 is converted to +6, 8. 8 implies this is 24. 24 plus 4 will reaches as what? 28 will becomes equal to the n factor. Thus, n factor for the compound consisting different elements which participates in a unique process of either complete oxidation and complete reduction will becomes equal to sum of n factors of all components involved in one molecule is taken as reference. In that way, we have to calculate the n factor value. A special case for the calculation of n factor, in some of the reactions what happens is the total material does not participate in unique oxidation state, whereas a particular element of a compound in the product state maintains its similar oxidation state, same oxidation state to certain extent, and the changed oxidation state to the other extent. In that case, how to calculate the n factor of the species in which for some portion of the material there is no change in oxidation number. For some other part of the material, there will be a change in oxidation number. Here, these are some balanced equations in which copper is allowed to react with HNO3, that is converted to copper nitrate followed by nitrous oxide and water amount formation occurred. Whereas this copper zero oxidation state is converted to +2, that is undergoing oxidation. Counterly, this particular species undergoing reduction, whereas the nitrogens related N factor, HNO3 is related N factor related discussion I am making here. For some portion, there won't be any kind of change in oxidation number, but for the some other portion, there is change in oxidation number. I took totally 8 molecules of HNO3. Out of these 8 molecules of HNO3, some 6 molecules doesn't maintain any kind of change, but it is a net change of what? 8 molecules. Officially 8 are taken, but out of 8 only 2 are involved in change in oxidation number. Hence, this N factor will reaches as here. For those two, the product oxidation number will becomes equal to 4, whereas for those two, the starting metal oxidation number becomes 10. Whereas this is not for one molecule, this is for 8 molecules. The net will becomes equal to what? 6 by 8. 6 by 8 implies what? This will be what? 3 by 4 will becomes equal to N factor for HNO3. If you want to calculate for this NO2 of +2 state comes from the +5. For NO2 only N factor will becomes equal to NO only N factor will becomes equal to 3. But this is with respect to the HNO3. N factor reaches as, yes, for this 6 there is no change, but you have to take those taken 6 into account. For the net 8, change in oxidation number is 6. For one molecule, 6 by 8 reaches as what? 3 by 4. Similarly, in this potassium dichromate on reaction with HCl results some KCl followed by CrCl3, Cl2 followed by water. Whereas if I take the HCl related N factor, some amount of HCl, Cl minus maintained as Cl minus Cr, Cl minus maintained as Cl minus Cr. Whereas I took 14 molecules. Out of these 14 molecules, for the 6 chlorines only, change in oxidation number was occurred. That is where it maintained as 0. That is coming from where? That is coming from the 6. So therefore, this N factor for the 14 HCl is 6. So therefore, magnitude if I take 6 by 14, 6 by 14 implies what? 3 by 7 will becomes the N factor of what? HCl. Thus, some portion, though it maintains its oxidation number without any change, but you have to take those as a part and part of total number of involved molecules. Thus, we have to calculate the N factor of the involved substance. Thus, the N factor of HNO3 for 8 difference is 6, whereas for 1, 6 by 8 reaches as what? 3 by 4, whereas for 14, the official difference is 6. For 1, that 6 by 14 will reaches as what? 3 by 7 will becomes equal to the N factor. Whereas the N factor of the product material, if you take into account, for this 2 comes from the 5. The change is every 2 comes from the 5 itself. For molecule difference in oxidation number is 3. N factor of NO becomes 3, but N factor of HNO3 becomes what? 3 by 4. Similarly, for this chlorine, if you want to calculate the N factor, this is 0. 0 comes from -1. Such of chlorines by number 2, and N factor reaches as 2, but it is not 3 by 7. Thus, you should be very careful. Every particular component of the reaction maintains its own specific N factor value, and that is not unique in every case for every material. That depends on the reaction, pH conditions, mediums, and many other factors also influence to decide the N factor associated with the materials. Thus, N factor of simple redox reactions, N factor of intra-redox reactions, N factor of compound of disproportionation reaction, N factor of compound of conproportionation reactions, and the N factor of the special cases where some materials, some components, some amounts components, change in oxidation number is no more. For some of the amount, there is a change in oxidation number, and individual N factors of all components of a reaction can be calculated with the help of this particular information.